Hello everyone. Today we are going to discuss about binary search tree and insertion and deletion operations on binary search tree. So first, insertion in binary search tree. So before going to insert an element into binary search tree, first we have to know about the basic conditions that all binary search tree should have. So first, the first condition is the element which is less than the root node should come to the left side of the root node, and the elements which are greater than the root node should come to the right side of the root node. This is the first condition, and the second condition is at each and every node this first condition should satisfy. That means by observing this image, so the root node is first, let us take the root node as 100, and the elements or numbers which are greater than the 100 are to the right side of the root node, that is 100th node, and the elements which are less than the value of 100 are at the left side of the 100. And let us come to the number 20 or node 20. So let us think it is the root node, and the number shot, so the left side the number is 10. That means the number which are less than 20 are to the left of 20, and the numbers which are greater than 20 are the right of 20. So at each and every node the two conditions are satisfying, so hence prove that it is a binary search tree. So to insert an element into a binary search tree, first we follow these two conditions. First, we check that number with the root node. So if the number is less than the root node, then we jump to the left side of the root node, or if the number is greater than the root node, then we jump to the right side of the root node. So by clearing or checking all the root nodes till we found the edge of the binary search tree, then we perform insertion. So if we are going to insert 40 for this binary search tree, first we check with with 100. So 100 is greater than 40, so the 40 jumps to the left side of the 100. So taking as 20 as a root node, 20 is compared with 40, so 40 is greater than 20, so it jumps right side of the 20. So in the right side of the 20, uh, it also has that element 30. So 40 checks again with 30, and 40 is greater than 30, so it jumps to the right side of the 30. But observing the right side of the 30, it has no element, that is null, so it occupies the space there. So it creates a link with 30 at the right side of the 30. So this is what in insertion operation happens. So let us know it about theoretically. So how to insert a value in a binary search tree? So a new key is always inserted at the leaf by maintaining the property of binary search tree. We start searching from a key from the root node until we hit leaf node. Once a leaf node is found, the new node is added as a child of leaf node. The below steps are followed while we try to insert a node into binary search tree. So first step, initialize the current node, say current node or node with root node. Compare the key with the current node as I said. So move left if the key is less than or equal to the current node value, and move right if the key is greater than current node value. Repeat steps 2 and 3 until you reach the leaf node. So okay, what do we mean by leaf node? Leaf node means the node uh, which doesn't have any child nodes. So attach the new key as a left or right based on the comparison with the leaf node value. So this is what happens in insertion operation in binary search tree. So let us move on to the deletion operation in binary search tree. So for this, given a BST, given the BST, the task is to delete a node in this BST, which can be broken down into three scenarios. That means to delete an element in the BST, there are three cases. So first, the the first case is to delete a leaf node in BST. So to perform this, we directly removes the link of the element with its root node. So for example, we have to delete a node 20. So 20 is a leaf node. So to delete 20, we directly remove this link from the root node such that this 20 element is deleted and root node 30 has only one child, that is 40. Case 2 is to delete a node with single child in BST. So what are the what are the steps to delete a node which has uh, one child? So let us take an element 70 which has one child, that is uh, 80. So to delete the 70, so to do this, we have to link the sequence below the delete element and the link it with the root node without including the deleted element. So for example, we have to delete element 70. So to delete element 70, first we have to assign the child node of 70 to any temporary variable, and we have to assign it to the root node of 70, and we have to delete the 70. So this is how the we can delete a node with a single child in BST. So let us move on to the next case, that is delete a node with both children in BST. So deleting a node with both children is not so simple as we thought. Here we have to delete the node in such a way that the resulting tree follows the properties of a BST, binary search tree. So to delete a node with both children in BST or two children in BST, so we have to find the in order successor or in order predecessor. So what is mean by in order successor and what is mean by in order predecessor means, in order successor is the minimum value in the right child of the node is the in order successor. That means if we want to delete an element 50, we have to find the minimum value, that is the minimum element in the in the right side of the root node. So in the right side of the root node, what is the minimum value element? That is 60. So 60 is the in order successor of root node 50. So what is mean by in order predecessor? In order predecessor means the maximum element of that is the maximum element found right side of the root node. That means what is the in order predecessor of 50? What is the maximum element in the right side of the 50? That is 40. 40 is the maximum element right side of the 50. So the in order predecessor of 50 is 40. So what is the use to find in order successor and in order predecessor means, if we want to delete a root node having two children, we have to replace it with the in order predecessor or in order successor. So let us consider in order successor. So what is the in order successor of 50? It is 60. So in the place of 50, we have to write 60. So 60 is written in place of 50 and 50 goes back to the place of 60. And then we have to delete the root node from updated tree, that is we have to delete the 50. So this is the final tree we have got. So this is how we will delete a node with two children in BST. So let us discuss about the code for this insertion and deletion operations in binary search tree. So all have a doubt that how we store the data, and we connect the both numbers in binary search tree in the form of code. So all of you studied about double linked list concept. So in double linked list concept, if we take a node which has a data partition and a previous address node partition which stores the address of the next node, and the previous address node partition which stores the address of the previous node. So same concept is applied in the binary search tree topic. So from taking these help of these nodes, we construct a tree in in binary search tree. So first we will discuss this code by parts, part by parts. So first we have to construct a node which have these three partitions. So let us construct it. So first we have to define the structure for a tree node. So first, there is no defined data type to a node. So we have to create a user defined data type which stores the node information or partitions. So first, to define a user defined data type, we use the keyword called struct, and the name of the user defined data type is node. So let us create a data partition which stores a data of elements. So all elements are int type. So all elements are integers. So we store it as int data, and we declare. So what does the left or right partitions of the root node stores? It stores the value, or it stores the value of the previous or next nodes. So what is the data type of previous or next nodes? It is also a user defined data type, that is struct node. So we have to declare the left partitions and right partitions of the node as struct node, because it stores the address or data of nodes of same data type. So first we are declaring a node data type. In that we storing data partition and left node partition or left partition which stores the address of the left node, and right partition which stores the address of right node. So the data type is created, but we have to assign the memory for the data types. So for that we have to create a node which stores the data. So to create a node, so to create it, so we to create a new node having data in it, we take a create node function, and in this function we are sending data or element which is inserted into new node, and going into this first, this statement struct node star new node is equal to struct node star a malloc size of struct node. So what does this statement perform means, first, new node variable equal to malloc. What does malloc do? Malloc assigns the random memory. That means it assigns the number of bytes we are going to give. So we are telling the malloc to assign the bytes of size of struct node. So what is the size of struct node? Data has 2 bytes, and left node also has 2 bytes, and right struct node also have 2 bytes. So totally 6 bytes of memory is allocated by malloc. But this malloc assigns the gives the memory in one byte, in the form of one byte. But we have to get the 3 partitions of 2 bytes. So struct node star. This statement tells that assign the data in the form of struct node defined data type. So in struct node defined data type, there are 3 data types which are storing 2 bytes. So this statement converts the 1 byte data 1 bit data type 1 bits into 3 partitions 2 bits. So and this node is assigned to the new node variable, and to define the new node, that is new node is a user defined data type, that is struct node. So we declare it as struct node star new node. Why this star is required means it points to the next node. So that is why we are assigning it as pointer variable. So next we have to insert the given data into data partition. So to insert it new node gives a new node of data equal to data. What this statement tell means, so normally a user defined data type, the data type uh, so this is the function to insert a node into a binary tree. So first we have to create a insert node uh, function. So in this function we are going to send the user defined function user defined data, that is root and the data partition which number we are going to insert. So first it checks that if root equal to null, that means there is no node present in the binary search tree. Then we directly uh, assign the new node to the binary search tree, that is return create node of data. So the new node of data partition is created, so that becomes the root node. If the case 2, that is there is an already the nodes are present in the tree. So in that case, if data is less than root of data, so let us think first this is the root node. So first the data is, if data is less than the root node, it we have to check the left of the root node. So root of left is equal to insert of root of left data. So what is the root of left? The root of left is 5. So again the in this function, again we are calling this function, in which this time we are sending root of left, that is we are sending 5 as a root node, and data part or element which are going to insert. So again it checks the function, that is again if root equal to null, in this case 5, root is not equal to null. So again it checks with the data. If data is less than root of data, again it moves the left node. Else if the data is greater than 5, we have to go to the next node. So this condition says this. Else if data is greater than root of data, we are going to send root of right and data into the this function again. So 8 is sent as root node with data if root equal to null, but 8 is not equal to null. So again it checks these both conditions up to the leaf nodes. So if So these functions clearly allocates or clearly follows the conditions of binary search tree and going to insert the element in the right position, and then finally we return the root node. So finally, what is root node? Root node means the new node of given data partition. So this node is going to return. So that's why we define the function as struct node star. So let us come to the deletion function. Let us create a function delete node, and we are going to send the root node and the data the element which is going to be deleted. So first it checks that if any node is presented uh, in the binary search tree or not. If root equal to null, that is no node is there in binary search tree, it returns root. So if any root node is present in the binary search tree, it checks that if data is less than root of data, delete node of root of left data. That means it finds that means these two conditions help the function to find where the deleted element uh, resides. So first, so after all iterations of this function, these two statements finally find the position of the deleting node. So after finding, it jumps to the this part of the code. So if the node with one children or no children, so to delete this, we directly unlink the uh, link between the root node and the current node. This code says that, and if node has two children, we find the minimum. That means what we call that is in order structure. We find in order structure, and we delete it, and we return the root node. So coming on to the main function. First, we iterate the while loop infinity times, the infinity loop. That means we are giving the full limitations for the user to enter the data on infinity times. That means user defined times. So first we are going to tell the user to enter the operation choice which you are going to perform, and if you are going to stop the process or operations, just click the or enter the 3 for exit. So it the code or the while loop stop iterating. If the user enters the um, unchoiced data, that is the data doesn't contain 1 2 3, it jumps into the default block or default case and prints invalid choice, please try again, and return 0. So thank you, hope this video helps you a lot. Thank you.